0 to s. So we know that this is going to end up being v squared over 2 evaluated from 0 to v, which is going to just give me v squared over 2. When I do this integration, I'm going to get my 6s and keep it as 0.02 over 2 s squared. And I'm going to evaluate it from 0 to s. Now I've left it this way for a reason, because I want to simplify this into something more manageable. So I get v squared is equal to 12s plus 0.0. Now things are going to get funky. So v is going to equal 12s plus 0.02 s squared to the 1/2. But I'm going to plug that back into here. So I'm going to end up with the integral of ds is equal to the integral of 12s plus 0.02 s squared 1/2 dt. First thing we want to see and notice is that this is a function of s, and I'm in the dt integral. This is a function of ds, so I've got to get this over here. So now I'm going to get that. So I'm going to get my ds 12s plus 0.02 s squared to the 1/2 is equal integral dt, which is going to give me t. Okay, in the back of your book, in the appendix, there are some integral tables. In your FE manual, there are integral tables. In your calc book, there are integral tables. They are going to become your friends, because this isn't pretty to integrate. Okay, this is not pretty to integrate. So if I go to Appendix A, I'm going to find this. I'm going to get dx, the square root of a plus bx plus cx squared is equal to 1 over the square root of c, the natural log of the square root of x plus cx squared plus x square root of c plus b 2 square root of c
Would there be a plus constant of integration along with that, or is that just it?
That's what the integral table gives me. And we're going to evaluate this from 0 to, we're going to evaluate this because we want to know where we are at 100. So those are going to be our integral limits that we're going to play with. So we're not going to have to worry about that constant of integration because we do have those limits.
Yeah, I got you.
So that you guys, or Appendix A, it's actually Appendix A in your book. Okay, so keeping that in mind, this is what we get. I get 1 over the square root of 0.02, natural log, oops, I did this wrong. that bracket's not there, that bracket's here, sorry. Natural log of the bracket, the square root of 12s plus 0.02s squared plus s square root 0.02 plus 12 to square root of 0.02. So the way I did it is I evaluated at 100 meters. And this becomes 7.07 natural log square root of 1200 plus 200 plus 14.155, which ends up, when you plug all the numbers in, you end up with 32.28. At 0, you still get the 707, except now you get the natural log 0 plus 42.55. And this gives me 26.52. So T is going to equal 32.28 minus 26.52 is going to give me 5.76 seconds.
That's the answer. How long the flight time was?
To get to 100 meters, yep.
Or how much it takes.
We'll do one more and we'll call it good. All right, this is problem 1231. We're going to be given the velocity is going to equal, let me write it out again. V is equal to V naught minus Ks. S is equal to 0 at T is equal to 0. We want to find the acceleration, the position as a function of time. So I'm going to start with ds is equal to my velocity times my change in time. Yep.
On that equation, is that V, what is that, minus Ks?
K, it's a
What is
constant.
Oh,
It's just a constant.
It's just a constant.
It's just a constant. So I'm going to end up with ds is equal to V minus Ks dt. I'm going to have to put this on that side, so I get ds V naught minus Ks. And that's ultimately going to give me my time variable. Okay, so I go to Appendix B. And I find that dx is a plus bx is going to give me 1 over v natural log a plus bx. So that makes that integral easy to do. So now I get minus 1 over k, because b is k. There's the negative, gives me that. I get the natural log v minus ks evaluated from 0 to s. So now I get minus 1 over k natural log v minus ks minus 1 over k natural log, because if I put a 0 in there, I'm only left with that. So now I have minus 1 over k natural log v minus ks plus 1 over k natural log v. So some reminders, I'm not done, even though I have a function, I'm not done, I have to clean it up.